So now we'll see the next concept. So far we saw when two pipes are open together and one is closed in the middle, or one by one if the taps are open, how to work out to find the time taken to fill the tank. So now if they ask all mixed questions like one open and in the half another other pipe is open and then again it is closed, all type of questions, we'll see how to work out with an example. So now we'll see an example where all concepts are mixed and given. So the question is, pipe A can fill a tank in 8 hours. Pipe B can empty the same tank in 3 hours. So pipe A is opened first, and after 4 hours B is also opened. After A and B together open for 2 hours, B is closed. Find time taken by A alone to fill the tank. So in this question, so first A is opened and it is filling the tank alone for 4 hours. And after 4 hours, B is open. Now A and B together fill the tank for 2 hours. And after this 2 hours, B is closed and we are asked to find what is time taken by A to fill the whole tank. So we'll see the working. So here two taps, two pipes A and B. So what is time taken by A to fill the tank? So it takes 8 hours to fill the tank. So what is time taken by B to empty the tank? So it empties in 3 hours. So time is less, efficiency is more, so you will have only overall emptying effect. So 8 and 3, what is LCM for 8 and 3? It is 24. So product of these numbers will be LCM. So 24 liters is the tank capacity. So assumed tank capacity is 24 liters. So if so, in 1 hour, how much water A can pour? 24 by 8, it is 3 liters. And how much water B can empty in 1 hour? It can empty 3 liters per hour. It can empty the tank in 3 hours. So in 1 hour, it can empty. So 24 by 3, it is 8 liters. As it is emptying, so we will have minus 8. So when both the taps are open, A and B together, so in 1 hour, so how much water will be there? So no filling effect, only emptying effect. So how many liters is emptied when both the taps are open? 5 liters. So B alone can empty 8 liters, but as A is also filling, so both the taps empty 5 liters. So minus 5. So minus implies that only emptying effect is there. So after taking this LCM, so whatever is asked, so you can work out this question like a story. So first A is open. And now when A is open, how many liters A can pour in 1 hour? 3 liters. So for how many hours A is filling alone? For 4 hours. So for 4 hours, 3 into 4, how many liters you have? 12 liters. And now at this point, that is after 4 hours, B is open. B is also open with A. So now A and B are there. When both the taps are open, so no filling effect. So it is only emptying effect. How many liters they empty in 1 hour? 5 liters. So for how many hours A and B are open? For 2 hours, B is open with A. So you have 12 liters here. In 2 hours, how many liters they will empty? So in 1 hour, 5 liters. In 2 hours, 10 liters will be empty. So what is filled here? 12 liters is filled. So in that, as B is open, in 2 hours, 10 liters is emptied. So now, you have only 2 liters. So at the point after 6 hours, so first A for 4 hours, so then B is open for 2 hours. So finally, it empties in this 10 liters. You have only 2 liters left in the tank. Now at this point, A alone is there, and now we are asked to find time taken by A alone to fill the remaining tank. So we have assumed the capacity as 24. So in this 24, how many liters you have at this point? Only 2 liters. Now how many liters you need? 22 liters is needed. So which tap is going to fill this 22 liters? A has to fill this remaining 22 liters. How many liters A can pour in 1 hour? 3 liters. So now to fill 22 liters, 22 by 3, or it is 7 1 by 3 hours, or 7 into 1 by 3 into 60, 20. 7 hours, 20 minutes is the answer. So when you assume time taken as LCM, so you can work out this without any, though it is a complicated question, so one by one you can solve this like a story. So first A is open, A pours 12 liters in 4 hours, then B is open. So in this 12 liters, 10 liters is empty, only 2 liters is left. So now A has to fill the remaining 22 liters. So per hour 3 liters to fill 22 liters, 7 1 by 3 hours, or 7 hours. So 20 minutes is the answer. So we'll see another example. So the question is, pipe A, B and C together can fill a tank in 12 hours. All the three were opened simultaneously and tap A closed after 4 hours. The remaining tank was filled by B and C in 10 hours. Find time taken by A alone to fill the tank. So earlier we found time taken by all the pipes to fill the tank. So here time taken by all the pipes to fill the tank itself is given. So ABC, when opened together, take 12 hours to fill the tank. And now they are open, and after 4 hours tap A is closed. Now only B and C are there. So these two taps, B and C, fill the remaining tank in 10 hours. Now what is time taken by A alone to fill the tank? So we'll see the working. So in this also we have 3 taps, but time taken together is given. So A, B and C together. So fill the tank in how many hours? In 12 hours. So normally individual time will be given. So we will take LCM for all time taken. So whatever time is given in the question which is needed to fill the whole tank, we can find LCM for that. So here time taken by all the 3 to fill the whole tank is 12 hours, and also the remaining tank B and C fills in 10 hours. So when you are taking LCM, don't consider the time taken which is needed to fill the remaining tank and all. So it will lead to complicated workings. So take time taken, LCM for time taken only for full tanks. So here ABC can fill a tank in 12 hours. So you have only one data here which is needed to fill the whole tank. So now only one value is there. We will assume that there is a tank which can hold 12 liters. So now ABC can fill this tank in 12 hours. It means in 1 hour how many liters all the 3 can pour? So in 1 hour all the 3 can pour only 1 liter. Okay. And now for how many hours all these 3 taps are open? For 4 hours. So in 4 hours how many liters they would have poured? 4 liters. So after 4 hours A is closed. Now which 2 taps are there? B and C alone. So B, C together fill the remaining tank. So we have assumed that tank capacity is 12 liters, and A, B, C, if they fill in 12 hours, in 1 hour they pour 1 liter. In 4 hours 4 liters is poured. So now how many liters are there? 8 liters needed. So this 8 liters is filled by B and C in how many hours? In 10 hours. So we have got the data that B and C in 10 hours can pour 8 liters. So we will take the base for ABC also for 10 hours instead of finding for 1 hour. So B and C fills the remaining tank in 10 hours, that is, what is the remaining tank? 8 liters. So B and C in 10 hours pour 8 liters. So now what will be the amount of water poured by A, B and C in 10 hours? So in 1 hour they pour 1 liter, in 10 hours 10 liters. So A, B, C together in 10 hours they pour 10 liters. B, C in 10 hours they pour 8 liters. So when B and C has poured 8 liters, how much A has poured in 10 hours? We get 2 liters. So we have got that in 10 hours A has poured 2 liters. So we are talking about A. We are asked to find time taken by A to fill the whole tank. So we have got the detail that A in 10 hours can pour 2 liters. And now how many liters we need for the whole tank? We have assumed it as 12 liters. So how many hours to fill? 12 liters. So now what will be the answer? So multiply 10 and 12. So by 2, 60. So here all these complicated workings we have worked out easily by this LCM method. So once you assume this LCM, so you can easily work out all this without any complication. So as there is only one timing given, so we have taken 12 liters is the assumed capacity. So in 1 hour 1 liter, in 4 hours 4 liters, remaining is 8 liters. BC in 10 hours fills this 8 liters. Now we'll check the same base for ABC also. So ABC in 10 hours, in 1 hour 1 liter, in 10 hours 10 liters. So BC in 10 hours 8. So A would have poured 2 liters in 10 hours. For 12 liters, it needs 60 hours. So it's not liters. So A needs 60 hours to fill the tank alone. So we'll see the next concept.